In 10 years, ESA's Mars Express has gathered enough data for scientists to make accurate 3D animated models of the planet's surface and a detailed mineral map that shows the location and distribution of key minerals. But the question about life on Mars remains.
We don't know if life started on Mars, but if it did start, it must have been the type of life that digests chemicals or minerals. So not photosynthetic bacteria like we have today producing oxygen, but more like the very primordial type of life we had also in the very early Earth.
Just as on Earth, the presence of life on Mars would be inextricably linked with the availability of water. And some of the components, like hydrated minerals detected by Mars Express, indicate that water was once present in abundance on the planet's surface for millions of years. Our solar system is over 4 billion years old. It's thought that all terrestrial planets had abundant water about 4 million years ago. But unlike the Earth, where tectonic activity has erased much of the history held in its crust, Mars, having had little or no tectonic activity, has very large preserved areas that are more than 4 billion years old. It's in these places where clear indications of water are present, with hydrated minerals and in some cases signs of lakes, rivers, and what could be rain channels. So what would Mars have looked like at this time? About 3 billion years ago, all that changed. Mars' magnetic field faded and surface conditions changed. The atmosphere dissipated and Mars became a cold, desertified planet. ESA's Mars Express mission, however, has been able to show that under the planet's coating of red dust, large quantities of water have been locked as ice in the planet's poles. It also appears to have found something else, something even more mysterious and intriguing: methane. The fact that this methane doesn't seem to be destroyed by the planet's hostile environment seems to point to a permanent source.
The fact that there may be methane there points to two possible origins, both of which are very interesting. One would be an ongoing hydrothermal process. Now, this would point to Mars being alive from a geologic point of view. The other possibility would be that there are bacteria living in the subsurface, just like in our planet, releasing methane. That would also be very interesting.
The mystery of methane on Mars is one that Europe's new mission, ExoMars 2016, is ready to solve. Its satellite will be designed to test for methane, and its rover, due to land in 2019, will be able to drill down and collect samples up to 2 meters beneath the planet's surface.
We will be looking for the first time in the third dimension being depth. And we think that is where we have the highest chance of making an interesting discovery regarding the presence of organic molecules in Mars.
So while Mars's secrets often seem cloaked in dust and buried in time, we've recently made rapid progress in piecing together the long history of this mysterious planet. A history that should also reveal a great deal about the planet's potential to support life in the future.